Good afternoon, class. We are looking at exam review, final exam review, the second part. Observations show that the length in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25. W is the power of 2.6, where W is the weight of the tiger. Furthermore, a young tiger's weight can be estimated in terms of its age, T in days, by the function W equals 3 plus 0.21 T. How long is the tiger when it's 100 days old? That's elementary algebra. You just basically plug in here. You find the weight. This is 21. And 3, it adds up to 24 kilograms. You plug this one in here. You do the math, and with a bunch of decimals, 969.369, almost 1,000 millimeters, almost a meter. So that's elementary algebra. For part B is asking at what rate is the length increasing when it's 100 days old. So we can use the Leibniz's notation, dy dt is dy du du dt. So we want the rate for the length, so dl dt. So let's write that. And basically L is a function of a W, and W is a function of T. That means the intermediate variable is W. And that's what this is. So dL dW times dW dt. This is a simple case. So with respect to W, 0.25 times 2.6, W to the power of 1.6. And this one is simply 0.21. And we multiply this number, and this number. We put it in front, 0.1365, W to the power of 1.6. And since we've already calculated when it's 100 days old, the weight is 24, you can plug it in here, or you can use, instead of W, 3 plus 0.21 T, and then replace the T with 100. Either way is fine. And of course, this is a faster way since it's been calculated. You put it into calculator, you're done. And the units of dl over the units of dt. Change in length over change in time, millimeters per day. A second method is to find the composite function. And because it's doable, you can replace the w with 3 plus 0.21 t. And now you don't have to use the Leibniz's notation. So first and foremost, this part you just plug in. If you were to calculate the length, just replace the t with 100. And this will give you the same answer that was found in the first place. And now L prime of t, or dl dt, is 0.25 times 2.6 times the same thing to the power of 1.6 times the derivative of the inside 0.21 by the chain rule. So you multiply this one, and this one, you put it in front. As you can see, this is the same as this one. Instead of W, now we have this one. And if you want the rate when it's 100 days old, replace the T, and you get to the same answer. It's very straightforward, not much to it. That's an application of the related rates. We want to find an equation of a tangent line, which means we are going to need two things. We need the slope, which means we have to differentiate. We need a pair, which is given. So to differentiate, we are going to use the product rule on this one, and implicit differentiation. So x gives us 1 times e to the power of y plus e to the power of y gives us itself times y prime or dy dx, and then times x. So this is f prime g plus g prime f in essence. The same thing here, plus y, the derivative is y prime times e to the power of x, plus now the derivative of e to the power of x is itself times y, and the right side. Any number will result in 0. You're done. You're going to solve for y prime by simply putting these two together that involves y prime. You keep it. This moves, becomes minus e to the power of y. This moves, becomes minus e to the power of x times y, or you put them in a parenthesis and a negative sign in front. So y prime is the right side divided by this parenthesis. Now we want the slope. We have to plug in the value that is given. So one way to represent that, m is y prime evaluated at the pair. So replace the x with 0, y with 1. So when we do that, this is 1. So the numerator is e plus 1. This is 0. This is 1. And the denominator is 1. And of course, don't forget the negative sign. So minus e to the power of minus e plus 1 over 1, or minus e minus 1. That is the precise answer. Now, because this is the y-intercept, you can just use the easy way out. Y equals mx plus b. So multiply, and by the way, this is an exact answer. You don't want to change it. Multiply this one by x and add 1, and that's it. And again, this is the slope precisely. It's roughly negative 3.71. And remember, e is 2.718, roughly. So it's negative 3.718. But this is an exact answer. You want to keep it that way. And we're going to move on. We want to differentiate. We are going to put a raised dot between e to the power of x and ln x. So it makes sense that we want to differentiate this. So we have e to the power of 2x times 2 times ln x. This is f prime g plus g prime. Ln x gives you 1 over x times e to the power of 2x. And just take out the e to the power of 2x. Well, you want to take the derivative of a log. The first thing is to decompose it if you can. There is nothing we can do. All you have to do, just take the derivative by flipping it over. So 1 over x squared plus 1. By the chain rule, you need the derivative of the argument of log, which is 2x. And you look at the base. If the base is e, you're done. If not, 1 over natural log of that. So we are looking at this formula. And you rewrite it so it becomes acceptable. There was not much involved here. However, when we look at a question such as part C, we don't want to go through that process. We definitely want to decompose it. So it's ln of the top minus ln of the bottom. Ln of the top is ln2 plus ln x. ln2 is a number. The answer is 0. ln x, 1 over x. Minus 1 over 2x plus 1 times its derivative 2. And now you're done. you are going to take a common denominator of x times 2x plus 1. So 1 times 2x plus 1 minus 2 times x, and these two cancel each other, and the numerator becomes 1. So being familiar with logs is extremely important. Here's another example that you are supposed to use logarithmic differentiation and logarithmic properties. So the first step is to take the natural log. In general, when you have a function to the power of function, you really have two choices. One of them to go with the natural, one of them represent this as an exponential. So if you take the natural log of both sides, then the left side doesn't change, the right side sign becomes the coefficient and comes in front. And now you can use differentiation. The left side is simply 1 over y times y prime. That means differentiate implicitly with respect to x, 1 over y times y prime. This is cosine x times ln x plus this is 1 over x times sine x. So 1 over y times y prime cosine x times ln x plus 1 over x times sine x. And so basically y prime is the right side times y. We're going to solve for dy dx or y prime simply by getting rid of 1 over y. When you put it on the other side, it becomes a product. So product of y and what is left, cosine x ln x, 1 over x sine x. And what was y in the first place? Replace it with x to the power of sine x. Differentiate x sine inverse of 3x. Reminding everybody the derivative of sine inverse is 1 over square root of 1 minus x squared. And the derivative of cosine inverse is the same thing, but a negative sign. Minus 1 is over square root of 1 minus x squared. So if you want sine inverse of u, so you replace the x with u, but 1 replaces with du dx. So this is the product of x and sine inverse. So first the derivative of x is 1 times the second piece, which is sine inverse. Now, the sine inverse, the derivative is in this format, or better yet in this format, because this is not x, this is 3x. So let's write it in this format. I'm not going to put anything here and anything here. So over here goes what you have here, 3x. Over here goes du dx, its derivative, okay? And then by the product rule times x, we're done. We're just going to rewrite the whole thing, okay? So this becomes sine inverse, this becomes 3x over the square root of 1 minus 9x squared. We are going to differentiate this. I'm going to put a raised dot to show everybody this is a product rule, product of these two pieces. So x gives you 1. And by the way, this is 1 minus x to the power of 1/2 for the sake of differentiation, easy differentiation. So 1 times cosine inverse x. Now plus, what is the integral of cosine inverse? Negative 1 over 1 square root of 1 minus x squared. So this one plus the derivative of cosine is negative 1 over the square root of 1 minus x squared, and by the product rule times x. So we're done with the first piece. We move on to the second piece. The second piece uses the extended power rule. 1/2 sits in front. And then the same thing to the power of 1/2 minus 1 or negative 1/2. And then by the chain rule, the inside gives us negative 2x. And now we are done. Take a look at this. We are done with differentiation, and we are going to rewrite it as follows. This is cosine inverse. This is minus x over the square root of 1 minus x squared. I want you to pay attention to this. 1/2. First of all, negative and negative makes it positive. 1/2 goes away. 1/2 goes away. And 2 goes away. So we have negative times negative x. X is in the numerator. This comes down, becomes the power of positive 1/2 or the square root. So notice this whole thing becomes this. These two cancel each other, everybody. As one has a negative sign in front, one has a positive sign, and we end up with dy dx being simply cosine inverse of x. The distance in meters of an object from a starting point is given by s of t, where t is time in seconds. What is the velocity from 2 to 4? This is elementary algebra class, rise over run, or the average velocity, the total distance over total time. So s of 4 minus s of 2. You do the math, you come up with the answer. So it's very straightforward, okay? The second part is taking the derivative of the function to find v prime. So the derivative gives us 4t minus 5. And we want it when it after 6 seconds, you replace the t with 6. And that gives you the velocity after 6 seconds of 19 meters per second. It's asking for the acceleration. Acceleration, by definition, is the second derivative of the position function. And so you take the derivative again. And that's a constant 4. And the units is meters per square second. By the way, after 6 seconds or 5 seconds or any other time, because it's independent of time, makes no difference. And as far as the units are concerned, please understand this is the same as dv dt, and that's why the units of the velocity over the units of time. And this is meters per second over second makes it meters per square second. When will the object reach 31 meters per second? The velocity set it equal to 31. And positive 5 and 31, 36 divided by 4 is 9 seconds. So very straightforward, everybody. A 180-degree turkey is removed from the oven and placed in a 74-degree Fahrenheit room. After 15 minutes, it has cooled to 136 degrees Fahrenheit. Find the general solution for T. So first and foremost, I'm going to remind you that the cooling formula, the Newton's cooling theorem, indicates that T of t equals y sub 0 e to the power of kt plus t sub s, where y sub 0 is t sub 0 minus t sub s. T sub 0 is the initial temperature, and t sub s is the surrounding temperature. So as the question is given, what is given? Initially, T sub 0 or T of 0 is 180 degrees Fahrenheit, where the surrounding temperature, T sub S, is given at 74 degrees. And 15 minutes later, T of 15 minutes is 136 degrees Fahrenheit. So those are the given information, and we will use all of them to get to T of T. So first and foremost, the Y of 0 is T sub 0 minus T sub S. So the difference between the two temperatures is what we are going to use as Y of 0, 106. And so now this has the formula 106 e to the power of kt plus 74. T of 15 is 136. So we're going to use this. So if you look at this formula, everything is there except k is missing. So we are going to use the fact that T of 15 is under 136, and we find the missing value of k. So first, subtract the 72 to get 62. Divide by 106. Take the natural log of both sides. This is intermediate algebra class, okay? Now, when you do that, the left side simply becomes 15k. Again, I haven't reduced this on purpose. Of course, you must reduce it when you represent it at the end, but what I want to show you step by step. So this becomes a 15k. This becomes the natural log that you have, and k is the right side divided by 15. And now you go with the calculator, you evaluate this, you divide by 15, and you put many decimals, okay? Because when you want to write this, you have to have a lot of decimals here to have a decent representation of T of T. So that's the first part. The second part says, how long does it take for the turkey to cool down to 110 degrees Fahrenheit? So now we set this to 110 and find the missing time. And so to do that, we are going to get rid of the 74. Subtract it. And that gives you 36. And now divide by 106. And again, I'm not reducing class on purpose. I want you to see everything. I'm going to take a natural log of both sides. Okay. And the left side is simply the exponent. Just the exponent. And the and the right side is just a natural log. And again, I haven't reduced it on purpose. Now, if I divide this one by negative 0.03574, I find the t. So I'm dividing this by this, and that gives me 30.2, roughly about 30 minutes. Could somebody read this, please?
A small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at a rate of 3 feet per second. Find the rate at which the area of the circle is changing when the radius is 4 feet.
Excellent. So what we are dealing with is related rates and a word problem. So let's write what is given. Number one, reminding everybody of basic geometry everybody is supposed to know. So here's a circle. Here's the radius. Diameter is 2 times that. If you go around it and you calculate the circumference is 2 pi r, and inside the area is pi r squared, and that's what we need for this question. So what is given? The radius is increasing. So dr dt is 3/2 feet per second. And we want to find what? dA dt at which point? The precise moment when the radius is 4 feet. So this is the translation of the question symbolically. And so to find the ADT, we are going to differentiate this with respect to time. So we're going to write the ADT is pi, and we are going to work on r squared and r squared only, which gives us 2r dr dt, or 2 pi r dr dt. And so we are going to replace the r with 4 feet and dr dt with 3/2 feet per second. And the 2's cancel out. We get 12 pi, and the units square feet per second. In other words, replace the 4 with 4 feet, 3/2 with 3/2 feet per second, or the change in area over the change in time. So the units will work. And if you want to write an approximation, use however many decimal they ask you. Bunch of decimals. All right. Let's find dy dt. It's important to pay attention the moment we see t. That means t is the independent variable. Therefore, even the derivative of x is no longer 1. So 4 times the same thing to the power of 3. We are looking at the extended power rule. By the chain rule, the derivative of the inside 5 dx dt plus dy dt minus x means minus dx dt, and any number results in 0. I can solve for dy dt. I don't need to. I can plug in, and that's just as good. We are going to plug in. This is 1. This is 15. And when we distribute, we get 60 plus 4 dy dt. And these two add up to 57. They move negative 57 and divided by 4, and we're done. So very straightforward, everybody. Could somebody read this, please?
A 20-foot ladder leans against a building. The base of the ladder slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet away from the building.
Excellent. So we have the building, we have the ladder, and it's moving this way, creating this shape. And as x moves this way, y comes down, and this is a fixed length at 20 feet. So this way, the speed or rate is dx dt 2 feet per minute, and this way we don't have it. We are looking for it. So what we are looking at is Pythagorean theorem. A squared plus b squared equals c squared, which means x squared plus y squared equals 20 squared. Dx dt is given as 2 feet per minute. Dy dt is missing at the moment that this base x is 12 feet. So this is again the translation of the question with the equation from geometry. So you always have to have a drawing to make sense of what you're doing and defining your variables. Let's differentiate with respect to time. 2x dx dt plus 2y dy dt, 400 results in 0. Although this is 400, any number gives you 0. We have everything you can plug in, and when we plug in, we notice y is missing. So you put the 12 into this formula to find the y when x is 12. Now we are ready to move in. We plug in everything we have. The missing dy dt can be found. Move the 48 and divide by it and by 32. In other words, this is minus 48, and we are going to divide by 32, both of them divisible by 16, negative 3/2 feet per minute. And as I've mentioned before, x is increasing, dx dt is positive, y is decreasing. This is getting smaller. dy dt must be negative, and it is. Would somebody read this, please?
Falling sand is forming a cone-shaped pile. The volume of the cone is increasing at a rate of 54 pi inches cubed per minute. The height of the cone is twice the radius of the base. Find the rate at which the radius changes when the radius is 6 inches.
Excellent, thanks. So what are we dealing with? We are dealing with a cone, and the volume is 1/3 pi r squared. That's a piece of information from geometry we should have. So the volume is increasing at this rate. So dv dt is this much, 54 pi cubic inches per minute. The height is twice the radius. So h is 2r. H is 2r. What are we looking for? We want to find the rate of which the radius is changing. So we want dr dt. At what point? When the radius is 6 inches. So this is, again, the translation of the question in conjunction with the equation from geometry, algebra, you name it. So the first thing first, volume is a function of the radius as well as the height. Because we are interested in dr dt, we are going to get rid of the height and use this, replace the height with 2r. If we were interested in dh dt, we would get rid of the r and write that as h over 2. So replace the h with 2r. Now you're dealing with one variable, namely r, and we are interested in dv dt. dv dt is 2/3 pi. 2/3 pi. I'm going to write that as a multiplier, a coefficient. Now r cubed, 3r squared dr dt. 3r squared dr dt, and we get 2 pi r squared dr dt. Now we just plug in and we find the missing value. As you can see, dv dt is given. You can solve for dr dt, you just plug in and solve. So this is given, r is given. So dr dt is 54 pi divided by this number. As you know, this is 36, 72 pi, right? And divide by it. The pi's cancel each other, and both of them divisible by 18, 3/4 inches per minute. So you just put it in lowest term. Any fraction, you have to put it in its lowest term. Use differentials to approximate the square root of 27. Number one, we need a function. And all you have to do is just read the question. It's asking for the square root of 27, so you want square root of x. The next one is finding the closest number to 27 that we can take a square root of, and that would be 25. Because square root of 25, everybody knows it to be 5. So delta x, we want to go from 25 to 27 and move up by 2. So 27 minus 25 is 2. It is important to know, again, if we were interested in finding, let's say, square root of 24, then dx or delta x is -1. Everything else is the same because we're going to, again, the closest number is 25. This time is negative. So we want to be careful with that. This we need to differentiate, and that is the reason we want to differentiate, because f of x plus delta x is f of x plus dy. This is the approximation of this expression, everybody. Remember, delta y is the change in y along the curve. Dy is the change in y along the tangent line. Delta y is precisely f of x plus delta x minus f of x, and dy is precisely f prime of x dx. We replace the delta y with dy as an approximation. And so f of x is known. What is dy? First, differentiate. So we're going to write that as x to the power of 1/2, and that we differentiate as 1/2 x to the power of 1/2 minus 1, giving us -1/2 or 1/2 square root of x, and dy is the same thing times dx. So now we are ready to replace f of x with this, dy with this. We want square root of 27 or f of 27, and that means x is 25, delta x or dx is 2. Plug in, square root of 25 becomes 5. We have 5 and 1/5 or 5.2. If we were to use a calculator, we would see that they are extremely close, and we are done. However, I like to do the same thing using linearization, which will give us the exact same answer. That means find the slope, find the equation of a tangent line. And to do that, you don't have to memorize that. Just stick with this one. That's good enough, everybody. Okay. So we need a pair, 25, plug in, you get 5, 25 and 5. And plug it into f prime, you get the slope, 1/10. So I'm assuming everybody remembers this stuff. Y minus 5 equals 1/10x minus 25. And this is y or L of x. Linearization means find the tangent line. What do you want? Square root of 27. That means L of 27. Again, I want to make sure everybody understands what's happening. When f of x is the square root of x, its tangent line at x equals 25 has this equation. Okay, you can evaluate a value such as 27 at the function, it gives you the exact answer. If you evaluate it at the tangent line, it gives you something close. That's the idea. We want to differentiate sinh 10x squared, and I remind everybody that hyperbolic derivatives, the derivative of sinh is cosh is sinh, tan, hyperbolic tangent is hyperbolic secant squared, so on and so forth. So for this one, the derivative of sinh is cosh of the same argument, namely 10x squared. And then by the chain rule, you need the derivative of 10x squared. This is the chain rule, which gives you 20x, and you put it in front and you're done. The derivative of cosh squared of x. By now, you know that the derivative of cosh is sinh, and the derivative of square root of so that's sinh. And then the derivative of square root of x, I have shown many times that it's 1/2 square root of x. Okay, so sinh of square root of x and times this. This is taking the derivative of this piece. Okay, everybody, by the chain rule. And we rewrite it as such. The derivative of hyperbolic tangent is hyperbolic secant squared. So hyperbolic secant squared of the same expression. By the chain rule, I have to multiply by the derivative of this piece. Now, what is the derivative of this piece? E to the power of 2x times 2. And I'm going to put this in front, and 2 e to the power of 2x, hyperbolic secant squared of 1 plus e to the power of 2x. We want to find the absolute max and mean, and this is using the closed interval theorem. Number one, you have to prove this function is continuous and where. This is a polynomial of 2 times 3. The degree is 2 times 3 or 6, which means it's continuous from negative to positive infinity. Therefore, it is continuous in the given interval of negative 1 to 2. In other words, the domain is there. And so you want to find f prime of x and set it equal to 0 to find CPs. You put the 3 in front, the same thing to the power of 2, and the derivative of the inside is 2x. You want to set this equal to 0. I mean, really, you should put the 2x between 3 and the parentheses, but makes no difference. Either this one is 0, that gives you 0, or this one is 0. Either this one is 0, or x squared minus 1 is 0. That means plus minus 1. So there are 3 answers. And all of them work because negative 1 is one of the endpoints, 0 and 1 are in between. So we are going to evaluate the original function at all of them. So you plug in negative 1. For example, if you put negative 1 here, you get positive 1 minus 1. That gives you 0. If you plug in 0, it gives you negative 1 cubed, which is negative 1. If you plug in 1, again, it gives you 0. If you give 2, 2 gives you 4 minus 1. 3 cubed is 27. So it's very easy to calculate all of it. Largest is 27, smallest is negative 1, and we write absolute max is 27 at this pair. Absolute mean is negative 1 at this pair. Now, again, the way they ask you to write it, you write it accordingly, okay? In order to receive 4 credit. The mean value theorem, given f of x equals 5 minus 4 over x, find all c in the interval of 1 to 4 such that the slope of the secant line equals the slope of a tangent line. That is really the concept known as a mean value theorem. The mean value theorem indicates if f is a continuous function in a closed interval of a to b, a differentiable on the open interval of a to b, there must be a number c in the interval of a to b such that f prime of c is f of b minus f of a over b minus a, or the cross product. F of b minus f of a is these two, the product of these two, f prime of c times b minus a. Please understand these two are the same thing. So first and foremost, you're dealing with a rational expression. If you were to graph it, looks like this, and you want it between 1 and 4. Okay, so what you're looking for is a tangent line that is parallel to this in essence. Okay, so you're looking for this, and it's between 1 and 4. By the way, there is another one, but between 1 and 4, that's what we are interested in. Okay, so we are dealing with a rational function, and this rational function has a domain all real numbers except 0, meaning from negative infinity to 0, union to 0 to infinity is continuous, and this means it's continuous from 1 to 4, closed interval, the endpoints are included. So first you explain what type of a function. X can't be 0, so this is the entire domain. We are interested from 1 to 4, and therefore it's continuous there. And of course, it is also differentiable from 1 to 4. So we calculate f prime of c according to this formula, f of b minus f of a over b minus a. So we want f of 4 minus f of 1 over 4 minus 1. Now, if we plug in 4, we get 5 minus 1, because if you plug in 4, you get 1. And if you plug in 1, you get 4. So I hope you see that, you can plug in and evaluate it. And the answer is 1. That means f prime of x, there is somewhere between 1 and 4 such that f prime is equal to this number. So let's find f prime of x. And I hope you know that 1 over x gives you negative 1 over x squared. So this gives you positive 4 over x squared, or I can show you again. So this one, you write another good color. You write 5 minus 4 x to the power minus 1. And to basically differentiate this, you get minus 4 times minus 1 x to the power minus 2. So that's why you have 4 over x squared. You set this equal to 1. You set it equal to this number. And cross product, okay. X squared equals 4. X has two answers, plus minus 2. And we choose only 2 because 2 is the only number in between the two, or these two numbers either. Now, before we continue, I want to remind you this is a mean value theorem. We also have the Rolle's theorem, which is a special case where f prime is 0. So this has 1 and 2 parts. The third part, if we add the third part, which says f prime is 0, it's called Rolle's theorem. So they are very similar. So you know one, you should know the other. Rolle's theorem. We want to find the limit, and we remember the L'Hopital's rule. The limit of f of x over g of x is x approaches a. If you can show, and you must, if it's 0 over 0 or infinity, infinity, you can take the derivative and do the math. If I plug in, I get ln 1, which is 0 over 1 minus 1, which is 0. So because it's 0 over 0, I can use L'Hopital's rule. So this notation, I use h to represent L'Hopital's rule. Ln x gives you 1 over x. X minus 1 gives you 1. And there you have it. If I plug in 1, I get 1, and I'm done. So L'Hopital's rule works like a charm, but it is important to show it that it's one of these two before you can use it. For example, in this case, I'm going to plug in and show you what we have. So if I plug in, I get e to the power of 0 minus e to the power of minus 0, or the same thing, minus 2 times 0. And the bottom is 0 minus sine of 0. And I hope you see that we get 1 minus 0 over 0. So we get 0 over 0. Therefore, I can use the L'Hopital's rule. So this gives me e to the power of x. This gives me minus e to the power minus x times minus. In other words, plus e to the power minus x. This gives me minus 2. This gives me 1 minus cosine x. I'm going to leave it for you to show that it is 0 over 0. Okay, if you plug in, you get 1, and 1 minus 2 is 0, 1 minus cosine of 0. And therefore, you can use the L'Hopital's rule again. This gives you e to the power of x minus e to the power minus x. This is gone. And 1 minus cosine x minus negative sine x. The bottom gives me positive sine x. I'm going to plug in. I get e to the power of 0, e to the power of 0. 1 minus 1 is 0, sine of 0 is 0. So that means I can use L'Hopital's rule again, which gives me this time e to the power of x plus e to the power minus x over cosine x. So Now, if I plug in, this gives me e to the power of 0, this gives me e to the power of 0, which is 2, and this is cosine of 0, which is 1. The answer is 2. Now, if I plug in pi over 2, I get 1 minus sine of pi over 2. Let me 1 minus sine of pi over 2 over cosecant, or 1 over sine of pi over 2. So the top is 0, the bottom is 1, and you're done. You don't need L'Hopital's rule. The point being, if one of them is 0, the top or the bottom, you can't be sure the other one is 0. You have to work it out. It may or may not be. There are different types of indeterminate forms, such as 0, 0 over or infinity over infinity. There are also types such as infinity minus infinity. And we try to convert it into a code. We have to show just either this or that. Nothing else is acceptable as far as L'Hopital's rule is concerned. Okay, so what do? We use a common denominator, rationalize factor, common factor to make it happen. For example, when we are looking at this one, if you plug in cosecant x, means 1 over sine x, and as x approaches 0 from the right is infinity, so it's infinity minus infinity. And so I'm going to write it as 1 over sine x and cotangent as cosine over sine. And now if I plug in, cosine of 0 is 1, 1 minus 0 is 0, sine of 0 is 0. So I get 0 over 0, and now I can use L'Hopital's rule. So the top gives me, this goes away, negative cosine gives me positive sine, and sine gives me cosine. And now if I plug in 0, I get sine of 0. Let me just write this. This gives me sine 0 over cosine 0, which is 0 over 1, or simply 0. Infinity minus infinity is not always 0. I want you to know that. Can be anything. The limit of ln of x to the power of 7 minus 1 minus ln of x to the power of 5 minus 1 as x approaches 1 from the right. If you plug in 1 from the right, you get 0 here, which makes it negative infinity. The same thing, 0 here, which makes it negative infinity. And minus infinity minus negative infinity means minus infinity plus infinity. And again, it's indeterminate. Please understand that this, when you plug in, you get 0 from the right. So if we plug this in, if you plug this in, you get 0 from the right. Okay. And you remember the graph of natural log, okay, looking something like that. So we can rewrite this as ln of x to the power of 7 minus 1 over ln of x to the power of 5 minus 1 using the quotient rule for logs, the reverse process. And so we want to take a limit of this. We can interchange natural log and limit because it's a continuous function. And so if I plug in, I get 0 over 0. And so because I get 0 over 0, I can use L'Hopital's rule. Take the derivative of the top, I get 7x to the power of 6, and the bottom gives me 5x to the power of 4. And now if I plug in 1, this becomes 7, this becomes 5. So the answer is ln of 7 over 5 precised. So infinity minus infinity becomes 0 here, but it becomes something else. They don't have to be the same. Use Newton's method to approximate the 8th root of 500 to 8 decimal places, and reminding everyone that from actually linearization, Newton's noticed that x sub n plus 1 can be written as x sub n minus f of x sub n over f prime of x sub n. So first, you let x be this. You have to show your work. If I raise both sides to the power of 8, I get x to the power of 8, 500. And if I bring up this one to this side, x to the power of 8 minus 500 is 0. So I let f of x be x to the power of 8 minus 500. It's important when we do Newton's method to show what is my f of x, what is my f prime 8x to the power of 7. You have to have them both. And now, according to this formula, if I want to write the general formula, I'm going to write x sub n plus 1 is x sub n minus. Now, f of x, I'm going to put x sub n to the power of 8 minus 500 over 8 x sub n to the power of 7. For example, I have to show work for x sub 2, and with that, I mean, what is x sub 1? Okay. So, because the 8th root of 256 is 2 and the 8th root of 61 is 3, we can use one of them. And because I've shown you about programming, even if you use one, it works, except without the programming that I've shown you, it will take forever, class. So we're going to choose this one as the first choice. So we're going to write this one for x sub 2. Okay, so we start with x sub 1 being 2, and we continue until it agrees to 8 decimals. And so we are going to replace the x sub 1 with 2 here, and this we will do it by hand or even use a help with the calculator. But this way, when x sub 1 is 2, x sub 2 is this number. So we really want to show at least some work. And I've shown you this easy method. You put y1 equals f of x, y2 equals f prime, and you store x sub 1, in this case number 2, into x, and then x minus y1 over y2 into x again, and repeatedly you enter. So when we write y1 and y2, the two functions, I'm showing you how to use it, for example, technologies such as TI. So you store the 2 in x, and when you press 1, this is the first one. That basically is what we got here. You do that repeatedly. And what you need to notice is this. We need 8 decimals. So this one, 1, 2, 3, 4, 5, 6, 7. This is the 8th one here. For the next one, if you go to the previous one, they don't agree. For the next one, 1, 2, 3, 4, 5, 6, 7, 8. These two are identical. And of course, you want to represent the answer, you have to do the rounding of number 7 becomes 8 because next to it is 6. So the process is to continue until they agree to however many decimals here. In this case, 8 decimals. We want to use the left endpoints, right endpoints, and midpoints rules with n equals 5 to approximate this integral of 1 to 2, 1 over x dx. Please understand, this is an approximation. This is the Riemann sum, and these are the formulas. Okay. And I want to first graph the function. The function y or f of x is 1 over x. This is the function y or f of x is 1 over x, and we want to go from 1 to 2, okay? That means we want this area, and it may be a little bit hard to show it here, but the concept is to, this is the area we want. And so we can cut this into so many pieces. We have been told to cut it into 5 pieces. So the best course of action, instead of memorizing that formula, just do what I'm going to tell you. Find delta x b minus a over n, calculate that. 2 minus 1 is 1 over 5. And then go from a to b, a line segment, and a is 1, V is 2, and just add this number 1.2, 1.4, 1.6, 1. And so forth. So for the left endpoints, okay, we want the height to be using all of this except the last one. That's the height that we are going to use. So the formula will use f of x sub I, f of x sub I. So we are going to use 1 over 5 times 1 over 1, 1 over 1.2, 1 over all the way to the last one, but it's not using the right endpoint B. It is not using B. Why? Because we want L sub 5. You put it into a calculator, tons of decimals, and you come up with the answer. Now for this one, it's important to see that we use all of those except the first one. And that being the case, it's a very easy calculation class because this part is identical to this part. And so calculating this is really not difficult at all. Okay. As far as the midpoint is concerned, we use this point, which is 1.1. 1.3, 1.5, 1.7, 1.9, so f of 1.1, f of 1.3, f of 1.5, f of 1.7, and f of 1.9, we are going to add them up. Using a calculator, we come up with the answer. So pretty straightforward, everybody. We want to use geometry to evaluate this. The integral of -3 to 3 square root of 9 minus x squared dx. And for now, in calculus 1, we haven't discussed how to find this using integration. So we have to use the geometry. And so reminding everyone that the function is square root of 9 minus x squared over the interval of -3 to 3. And also reminding you of the formulas for various circles. Centered at 0, 0, x squared plus y squared equals r squared. Centered at h and k, x minus h quantity squared plus y minus k quantity squared is r squared. Here's the circle. And so if you square this, by the way, let me show you how we get here. If you square this one, you get y squared equals 9 minus x squared. When you move it, you get to this one, which is a circle centered at 0, 0 with the radius 3. So looking like that. And this is the semicircle. So it's half. Okay, so the graph of G is a semicircle of radius 3. So it's half of pi r squared, where r is 3. So you get 9 pi divided by 2. That's how you arrive at the answer for this question.